Thanks for coming all this way, guys.
Thank you very much. Thanks very much. I'd like to say that it's a great pleasure to come this far. I'm really excited about the interactions I'm having as part of this visit. I get to interact with a graduate class, and I met with or heard how an undergraduate class was discussing this work today as well. Bit of dinner and drinks tonight, and I enjoyed a great day of skiing yesterday. So I'd like to thank the Bevan sponsors for bringing me here. As David said, I work for CSIRO, which is Australia's national science agency. One of those divisions works in the ocean space, and that's our labs on the foreshore, the 3 long buildings there in the city of Hobart. My collaborators whose work I draw on today for the presentation are based at CSIRO with me, and then also at the Bureau of Meteorology and the University of Tasmania. But part of the, the fun and enjoyment I get out of science is the group of people I get to work with, and we have, friendships that develop around the world through being able to have a career like science. And I feel, really fortunate to have these great experiences with really fun people to work with. Climate change has a range of impacts on the ocean. And through this putting of carbon dioxide into the atmosphere, there are 2 main pathways where it hits the ocean. And the first one is just through warming. So warming does a bunch of stuff to ocean processes, like change the depth of the mixed layer, influences circulation and so on. And any climate skeptic in the world can say, oh yeah, but that's just natural variation, we don't have to worry about that. Unfortunately, climate does a second thing, which is increase the pH of the ocean. Through increased carbon dioxide in the atmosphere, that dissolves into the ocean and makes things uncomfortable for marine life now and potentially for a very long time in the future. And no climate skeptic I've come across has been able to explain away how we could have ocean acidification without humans being a contributing factor. So the ocean has a really important role to play in explaining to people about why climate change is going to be problematic for our planet for a very long time. When I started working on climate change, it was pretty much by noticing around Australia we're seeing really dramatic warming. And over the past 100 years, the rate in Australia is really very fast compared to other places in the world. The background rate of warming over the last 100 years had been this about 0.6 or 0.7 degrees over a 100-year period. And in the 4 corners of Australia, we're seeing much faster warming. And we knew that from observations at each of those locations. And where I'm based in the southeast there, we're almost 4 times the global average rate of warming. Really dramatic. So if it's really dramatic in that particular place, we should see really dramatic changes in biology already. And we've done that. So climate change in Tasmania and Southeast Australia is not coming next year or the 10 years or 20 years in the future. It's kind of coming now. And when I can explain to you later why some of our interventions and adaptation strategies are working so well, it's because we've got this overwhelming weight of evidence that the heat about is climate change happening or not in this sector has really gone away. And we've been able to move very rapidly to the next stage about what are we going to do about it. And so our teams and others in Australia have worked really hard at documenting that evidence of fish changing distribution, of plankton changing distribution, impacts on fisheries, toxic algal outbreaks and so on, and really clear evidence from a whole weight of studies throughout the ecosystem. And then we started thinking, well, if we're seeing dramatic changes in our part of the world, where else might be seeing these dramatic changes? Because unfortunately, when it's changing rapidly where you live and you think it's the only place, you think you have to invent everything there. If you look around the world at other places that are warming rapidly, maybe you'll learn something from talking and meeting with those people. And so this analysis is just a simple trend analysis of the rate of warming over the past 50 years. And there are dark red areas and even some blue areas where we're seeing a bit of cooling. And kind of the polygons mapped over the top are about the 20 or so fastest warming places on the planet. And so we've tried to set up a network with some of these other countries in the southern hemisphere where we can see what's happening in those areas and try and develop strategies together to cope with that. So the particular one, again, where I've learnt my lessons mostly has been in the southeast of Australia. And after we'd done this work and started to put together what was going on around the world, it's really, really dramatic. And so for Southeast Australia, this is a representation of the marine food web. And everywhere where there's a black circle on that diagram, we've got a documented impact of climate change already. Where there aren't circles, it's probably because we're not looking yet. Nobody's studied the detritus or the sea cucumbers yet in this region. But when we do, I'm pretty sure we'll see impacts of climate change as well. So again, the weight of evidence has taken the heat out of the argument about whether climate change is real or not in our particular area. We've also got pretty clear signals from climate models that the climate is going to continue to warm in this area. And here's one way that we use to explain to people in a way they can perhaps relate to. And that shows the number of years in that decade of the 20s that the ocean will be hotter than it's ever been before in that spot. So where it's really dark red, 9 or 10 years out of 10 are going to be much hotter than before. In places where it's more blue, maybe the variability is still pretty high and only 1 or 2 years are going to be particularly unusual. But again, you'll see particular hotspots that are warming, like our east coast of Australia that I have boxes, right through the tropic, the very far north of Alaska, are places where the warming is expected from this particular single model from the UK, that we're going to see strong warming. And that warming is going to be coupled with extreme events. I know that we'll have ones that we're familiar with here in North America, but in Australia we've had a marine heat wave on the west coast of Australia that caused a lot of disruption to fisheries. We've had cyclones and flooding associated with those events that have been given a climate attribution. Through studies now we can kind of say the answer that this event was more probable because of climate change. And again, in the southeast we had a really strong marine heat wave just last summer for us over the 2015-16 period. And that heat wave, it's our blob. We haven't got us a sexy name. We've struggled hard about what to actually call it. We are, the Tasman Sea Marine Heat Wave didn't really grip the emotions like I gather you had here. But in terms of what that event was, in terms, again, creating awareness about what climate change is going to do to systems, from 1983 to 2015, this is how long each of these heat waves that we've seen in this area has lasted for. And this current event lasted for over 200 days. Its intensity was also the biggest event that had ever been seen in that region. So again, lots of biological evidence, very strong projections, and now extreme events happening on top of that. And so we have very clear climate impacts on fisheries. It's very clear there are going to be distribution changes. Very clear there are going to be abundance changes. The time of year in which animals do things, their phenology is going to change. And again, we'll have environmental impacts like disease outbreaks and productivity changes in the environment. No disputing that from our group of stakeholders. And so fisheries and fishers have to adapt to these changes, and in these fast warming areas they're going to have to do it very quickly because those changes are already there and life is being disrupted. So we get it, the climate's changing, is basically what our stakeholder group is telling us. But while they get it, they still think they're going to be pretty good at coping. And Australia also has a lot of droughts, and when we have a drought or a really bad event, the news media goes out to the farm and it interviews Farmer Bob and says, that's a pretty bad drought, how are you coping? Oh, it's terrible, it's the worst we've ever done. Well, what are you going to do? Are you going to be back next year? Oh yeah, we'll be back next year. We'll be back here doing exactly the same thing. Because the badge of courage in Australia comes from sticking it out in an unfavourable environment. Well, the smart thing to do would be, no, this was terrible, I'm going to move somewhere else and do my farming in the next place over. Fishers are like that too. You get slammed by all kinds of environmental events, but no, we'll be back there again. And that image is held up as the noble thing to do. We should support the people who are on the run. Go somewhere else. And so their ability to cope with these changes, I think, will be very difficult despite their personal beliefs that they can cope because they've coped in the past. They won't be able to cope as well in the future because their experience is not going to help them. You see novel combinations of physics and biology and chemistry that create new events in the ocean that they've never seen before. So how do you use your experience to manage your business or your fishery when you have never seen those events before? And so that puts them in a place where we can help, because we can help them with risk-based decision making. Given what we know, how can we help you do your decisions around your business of fishing or farming or forestry or whatever it is? And we can help them not with mitigation solutions, which are generally applied at a global scale, and that's solving the big problem of climate change, but we can help them with adaptation, which is what can you do to cope with these changes that you're going to experience regardless of what the planet decides about mitigation. And if you get on it early enough and help with adaptation strategies early, you should have many more options. So while these areas are warming very rapidly, the quicker you can get something into place, the more flexibility there should be in a system. And it's particularly important to get adaptation right for natural systems. This is some schematic that shows projections of how much the planet is going to warm. And depending on which particular story pans out, we'll have different levels of warming. And this burning embers plot shows that depending on the amount of warming, when things become critical for different systems. And where it kind of turns into red, that's where things become problematic. And so in the first column, water security will become problematic with about 2 degrees of warming. Major infrastructure can probably handle 5 or 6 degrees. So if you live in a big city that's well engineered and everything, you may be fine up to 4 or 5 degrees of temperature change before things really actually worry you in your life. But the unfortunate part is natural ecosystems is going to be the most vulnerable. So the rest of some parts of the world might live quite happily while the natural systems get hammered. And so the amount of mitigation really matters. If the world does a great job of mitigation, it will hold down that level of temperature rise, and the adaptation will only have to fill a little bit of that gap. If the world does a lousy job of mitigation, the adaptation solution will have to be much larger. Can we help things cope with a much larger gap? And the worst outcome would be actually mitigation is lousy and adaptation can't fill the gap. And in that case, you might have decisions to make about, in the case of fisheries, do we let them go? There is no solution that we can actually invest in that's going to fix that problem. And I did point that out about natural ecosystems being the most vulnerable. And of course, fisheries depend on natural ecosystems. So as far as options for fish, there's actually plenty of those. And trust me, we could invent adaptation options that would help fish cope. So let me just say, that's all I'm going to say about fish adapting. Read some papers. We can do that for fish. And these are interventions, that we would do for fish. Move them around, genetically engineer them, recreate their habitat, do a bit of rescuing, right up to actually ex situ conservation, which would be an adaptation strategy if those 2 arrows didn't meet. Let's take our fish out and put them in a gene bank until the world gets to be a happier place. So I'm going to talk instead about fisheries, because they're going to rely on the biology and they're going to need some help to adapt. And so if you want to be able to do that, you need to develop some adaptation options. They have to be technically appropriate, society's got to be okay with them, and they've got to be institutionally possible. So there's a bunch of things that you might have to go through in selecting those, and I'm just going to illustrate the vulnerability framework about how we would actually generate adaptation options for fisheries. One model that people use is an exposure sensitivity and adaptive capacity model, and it says we're vulnerable because we're exposed to climate change, we don't like it when it gets hot, and we've got nowhere else to go, as being the 3 components that make you vulnerable. You could apply that to people as well. We're exposed to hot temperatures, we can't cope when it's over 40, and we've got no air conditioning. That would be the kind of scheme there that would give you a potential vulnerability. But the important thing in fisheries is they're a socio-ecological system, so you've got to put those 2 things together. And so the ecological part actually influences how vulnerable people are as well. Obviously, if the fish is living somewhere else, then the people will be challenged also. And we use this model to work with stakeholders to actually develop the adaptation options. So there are options that you can do to reduce the exposure of the fish. Let's move it somewhere else. The sensitivity, let's genetically engineer it. The adaptive capacity, let's make sure it's not overfished. And then the sensitivity of the people part of it is, can they go to other industries? Are they reliant on fisheries only? Their adaptive capacity might be influenced by their educational level, their ability to read the internet and find new solutions and so on. And so we'll present this to a group of stakeholders, work through it with them, and then end up populating it for something like this one here, which is for coral trout fisheries on the Great Barrier Reef. And the text is just to say, for each one of those options, when we work with managers and policy makers, we can actually come up with a variety of things that might be potential solutions. And I suggest that's a really good thing to start with as a first step when you work with a group of stakeholders or a fishery, is to go through that and do that brainstorming. Give people the courage and the space rather, to be creative with what the options are. Because even something that's unpalatable today might be a very appropriate option in 10 years' time. Some of these options will be very novel. One bloke in Australia proposed that we should bring elephants to Australia to graze down the grass that was causing huge bushfires. If you want to get published in Science or Nature, you have to say something crazy like that. The other scientists who didn't think of it, they all get to write letters of outrage. So, and of course we never do that, and the science machine goes on. But I think novel conversations are really important to have. You've got to be able to talk about options that might be palatable to some people or at some time. And unless you have trust, you won't be able to build those novel conversations that I think are really important in generating adaptation solutions. If you're good at generating adaptation solutions, you can move to a kind of a place of proactive adaptation. So when we get hit by a storm and decide to do something differently, that's reactive. We'll just do something better next time. And that's a really, really lousy way to run your business or your fishery. Every time you get whacked over the head, you'll decide you're going to move a little bit further. What if you could see the whack coming? Would you do things differently? And we would argue that if you can anticipate that change, that gives you, again, a whole bunch more solutions that you can implement. And you should be able to improve your business performance, and the ecological sustainability of the fishery should be better. So again, these kind of win-wins. So if we can give people more information about the future, how do we do it? And there's a range of scientific techniques that we can use. We can forecast distribution with spatial models. We can forecast abundance of fish with population models, and so on. If we want to test management in the future, we can do management strategy evaluation. If we want to test human behaviour in the future, actually I don't know how we do that, but there should be ways that you can also test and examine human behaviour. We just don't have very much maturity in that space yet. But when we talk to people, they said out of all those great options, just tell us where the fish are going to be. They didn't want to know all of those other things. So great, science community went away. We beavered away together and we did a bit of distribution modelling. Now how do you do that? In a nutshell, you get some observations of a fish, you get some matched observations of the environment, you crank it through a model, you do a bit of testing of how good your model is, a validation method, and then you make a map. If you want to do it for the future, all you do is replace step 2 with environmental data from now with some environmental data from a climate model. And in a nutshell, that's how you make a projection about where fish are going to be in future. And so away the science community went, and they built them with distribution models. And that just says here, this fish likes temperature between X and Y, 10 and 15 degrees. Let's run that and see where that temperature envelope will be in future. And so we did wonderful stuff. I said by the year 2100, all of these fish will move further south on the coast of Australia. Other people said, yep, tuna will move from the left-hand side of the ocean to the right-hand side of the ocean by 2100. By the 2060s, we said different stuff would be happening in the ocean. Fish catch, how would that change? Are they kind of just cranking the handle models to spit out distributions and how animal abundance is going to change at quite long time periods into the future? And the response was, well, that wasn't very helpful. You might have got a few science papers and a few nature papers and your colleagues were very happy with you, but for people trying to adapt, 2100 is no help at all. And yet our science community has spent probably a decade focusing at that level of projection for biological problems. I think it's too far into the future. And the reason I think it's too far in the future is that the number of decisions that you make actually decreases the further you go into the future. So if we want people to get better at using information, why don't we start giving them lots of stuff at short time scales, get them practicing and getting better at making decisions, and then when they need to get to the long time scale, they should be better at it. At the moment, the only people who can use long time projections are policymakers, other scientists who want to summarise it in IPCC assessments or condition some experiment about what the world might be like in 2100. But other than that, I'm going to say to you, Julia, with your email charged me, this is kind of useless. And so if you want to work better with different timescales, you've got to understand the decisions that people make on those timescales. And again, this is a type of device we use when we go into a stakeholder community and we say, well, what decisions are you making in your business at these different timescales? And if we can understand what those are, we can design a solution for you. And in general, weather forecasts don't give them enough time to really be strategic. When you get a weather forecast as a fisherman, you're really only deciding, am I going to sea or not, and what am I going to wear? At the climate scale forecasting, no fisherman's making a decision at that 100-year time scale. But something around this seasonal weeks to months might be a sweet spot where we can give information that really does help with adaptation. And so we've argued in our work that that's the most useful scale to train people at being proactive in marine management and also get better at adapting to climate change. So again, my suggestion is we start to do that kind of decision mapping for a whole bunch of problems where people are faced with adapting in the future. And it's, again, a really good conversation piece about, well, what decisions do you make and how would the information I do for you as a scientist help you? And so as part of that, 10 years of making long-scale climate projections, our group came back and started focusing a bit more at the seasonal time scale. And we now deliver 6 or so different operational forecasts to fisheries and aquaculture businesses in Australia. They're getting these now, every week, telling them about future conditions up to 6 months in the future. Sorry, not up to 6 months, 3 months into the future. We do it based on the Bureau of Meteorology's climate forecast model that produces these seasonal forecasts. This model can spit stuff out to 9 months in the future, but we haven't found it ever works out that far yet. So we do have to do a lot of evaluation and see how long those predictions are reliable for. And as I said, it's about this 2 to 3 months maximum is what it's able to do. And I'll give just one example, which is the southern bluefin tuna fishery. We got asked to do this one because the graph on the right shows the temperature in that red box increasing over time. It's a 10-year trend. Is it climate change? Who cares? They're experiencing a change in their fishery that has meant they're experiencing some problems. So we could actually help them understand the changing fish distribution. If they know where the fish are, they can do a better job of catching them. That improves their profit, and maybe they're in a better place to adapt. So in this particular area, bluefin form these huge schools. And you go out in a fishing boat, put a purse seine net around them, and transfer them into one of these huge cages, which is then towed back to port. You can only tow one of these cages at 2 knots, and it takes 3 weeks to get to the fishing ground. So if we give them information 3 weeks ahead of time, they know whether to head the boat this way or this way. But once they've made that decision, there's no turning around and going back to the other fishing ground. And with the fish changing distribution, they were sending the boats to the old place. When they get there, the fish aren't there. So our information on forecasting could help them overcome this changing distribution problem. And we get some habitat preferences that the fish likes. It likes 20 degrees up on the top left. We ask what was available in the ocean, which is the range of temperatures in the lower left, and put them together to make a relative preference curve. And that's a really simple distribution model. What is it choosing out of what's available? And when you can do that for a whole combination of variables. In this case, it's both temperature and chlorophyll in the top left, which makes like a hump. You lay that hump over what's available, and again, you end up with another preference surface. And you can make a map. And the one on the right is what we produce. And the area where it's the bone coloured is our suggestion of where the fish are going to be. And if you're steaming out from a fishing ground, which is here at Port Lincoln, you've got to get that distance there of about 300 kilometres, and it'll take you 2 weeks to get there towing the boat, towing the cage. If the fish are not going to come to you, you better get going now. But if that habitat is going to get closer to you, maybe it would be economically advantageous just to wait there until the fish arrived. And then we deliver a forecast. This is the natural resolution of that forecast on the right-hand side, and you can see they're pretty blocky. And we had a big debate in our team about should we smooth it and make it look more like the real ocean to make it more believable for fishers. In the end, our philosophy was we shouldn't do that because it reminds them that it's only a model. And if I made that look all smooth and beautiful, like the one on the left-hand side there, it would, I think, be deceptive about what the quality of the model can actually do. So they have to learn to make decisions around the quality of where those bone-coloured boxes are in the left-hand set of panels. And that's giving them information for the next 2 weeks, 2 weeks after that, the following month, and the third month. And in this case, you can see fish are quite close to the port, and then that bone habitat is retreating back towards the west as we go out. So better get out and get your fish now, or you'll be towing your cages for a long way. And we deliver this through a website that's only available to the fishers who for the first year, and then they let us make it public. So now anyone could look on and see these particular forecasts. There are 10 major fishing companies. They all looked at the website in the first year, and when we surveyed them, 8 said they used it to make a decision. In 2 cases, the decision was we're going to do what we're always going to do. And that might have been because they didn't understand the forecast, or their operation was quite flexible with regard to what the environment might have been saying. 6 different companies, though, made decisions based on those forecasts in the first year. And that's a great uptake. They made a decision about when and where to go fishing based on information they were getting from the first year of a forecast. Which, a great success. What we don't know is what's the economic benefit to them. And even though we thought we had a great trust relationship, when we said, well, how much money did you save by doing that? Oh, no, we can't tell you that, And that's a frustration, because for us to sell benefits to other groups, we'd be able to say, we saved them $2 million over the course of this season. We don't have any idea, well, we can guess at the number, but it would be great to have, very good data. So getting data from fishers on the economic benefits you'll know is hard work. So the response, that was great. We can use that information. That's at a time scale that's useful to us. Why is this approach working in Australia? I think it's because we have a kind of a three-step model. We spend a lot of time with them assessing their need, asking them, what's the that time scale slide that I showed you, where we had all the decisions stacked up. We determine the critical variables and decision timescales. We try and get verification data that the fishery itself has produced. So we're going to use your data that you understand to verify our model. And that builds a very strong element of trust. We both value what they have and we can use it in our modelling approach. Then the traditional step, which is develop a model. And that's typically what as a science community we do. We build a model and we throw it over the fence and say, there you are. That often doesn't work because you don't do the implementation part right. Think about how you're going to deliver it, what support and education you're doing for the fishers. In the case of this bluefin tuna example, we had an industry representative on our project team who did weekly briefings with the fishing companies in the fishing town. That was very useful for us. And then we also try and get their decisions back from them. So we know what they did with it, which means we can do a better job with the forecast products. And often as a science community, we tend to skip that step. We just like the sexy bit of developing models in the middle, throwing them over the fence and hoping that someone will pick them up and use them. And I think our approach has worked because we've paid attention to the step A and step C in this particular example. Is it helping them get better at preparing for climate change though? If it is, this hypothesis will be true. The better they get at using seasonal forecasts on the x-axis, the more their performance will improve with regard to long-term planning. I don't know how to test that. We'd love to test it, but we can't wait 100 years to see whose business is still surviving and then match that back to whether they used our forecasts or not. So, if we have beers tonight or tomorrow, it would be great to talk about how we'd actually test this. Can we train people to be better decision makers by giving them lots of opportunity at short time scales? And after going through this step, it's actually just led us to the point that we now understand how to use the climate scale forecasts together with the seasonal scale forecasts. And so this is trying to put those two things together again. Remember I said 100-year forecasts are a waste of time. Now they're back on, they're good news, everyone who works on 100-year forecasts. We start off with a decision tree and we ask, is the current area suitable now? You only need to have information on your current environment to know the answer to that question. If the answer's no, you could go and look at other suitable areas. Again, that's just using current information that you have. But if the answer comes down to the second row, is the area suitable in future? You really need climate projections to answer that question. So again, we'll show pictures of what the future climate is going to look like and evaluate whether or not it's going to be suitable for the particular fishing operation. And then finally, depending on whether the current area is suitable now, you can use seasonal forecasts to help cope with the variability that's happening as it gets hotter and hotter in that particular place. So putting the climate with the seasonal. And I'll illustrate here. So here's some downscale model results that we have for the end of the century. It shows the rate of warming. And so again, the east coast of Australia is going to get very hot. So we would think that businesses in that area that are in fishing and aquaculture need to do a bit of adaptation, as I keep hammering. And then the climate model shows, for these 4 boxes of the east coast of Tasmania, the trajectory of temperature out for 100 years. And for this particular species that we're going to say is sensitive, it needs summers below 18 degrees Celsius. When you're far to the north, those 2 red dots connected by a red line show you the period of time that you first get above 18 degrees and then you're never below it again. We call that the first emergence and the last emergence. And that's the period of time that the environment's sometimes good, sometimes bad, sometimes good, sometimes bad, and then it becomes bad forever after. And that's the period where you can use seasonal forecasting, because they have to cope with that risk every year. Are we going to be above or below our good conditions? And in this case, as you come from north to south, you can see that pair of red dots moving slightly to the right. And that's because as you go to cooler waters, you don't need to even begin using seasonal forecasting to here really, the year 2030, because the environment's below the critical threshold and fish presumably is doing great. Then we'll start using seasonal forecasting, and by about here we've got to move or do something else. And our climate model tells us how long we've got in that particular location. And that brings an economic benefit to them, because at the moment we might think that the environmental suitability can be either good or bad. If it's good, we make a lot of profit. And then that profit deteriorates when the environment becomes worse. And the cost of doing business in that area of fishing and maintaining all of your equipment goes up. And perhaps when those two things cross over, that's the time at which you would choose to leave that particular region and go somewhere else. But if you have a forecast, your seasonal forecast should increase your profits in bad years and decrease your costs in good years. So those, sorry, I said that, it should decrease your cost in bad years and increase your profit in those bad years as well. And so if you can do that, now the crossover time has come forward a bit. And so we can persist in a lousy environment for a bit longer because we're using seasonal forecasting to make sure we win in the good years and don't lose too badly in the down years. So now we can say, well, if you adopt this kind of system, don't panic, the climate's changing, but we can help you adapt and manage in that space. Oh, that's much better. We'd like more of that, please. Oh, okay, we'll give you more. We said, well, your fishes are all sorted, but your reason you catch fish is because you want to supply a market. And you supply a market through a supply chain. And so product goes from the left-hand side with the catching all the way through a bunch of stages out to where it meets consumers. And it turns out that different parts of these supply chains are actually vulnerable to climate change. If you have to take something through an airport and the airport gets closed due to flooding, well, it's as if the fishery was impacted because that product is not getting through. So we've developed an analysis based on food webs that identifies critical elements in these. And in this case, they're coloured in a little bit of a funny colour, things that should also have to adapt. And so, yeah, these supply chains can be represented just like social networks or food webs. Energy moves through a food web, seafood moves through a supply chain. And based on how much product is flowing through those, we can create metrics of how that food web, how that supply chain is performing. If this top one here, it's pretty linear. If you break any one of those links, because climate change gave you a disruptive event, a flood, a drought, just it was getting too hot and the train tracks were getting all bent, whatever it is, that's not very resilient. But one with a lot of links in it, just like a food web, is more resilient to the impacts of climate change. And so, as well as identifying the critical elements, we're now simulating climate shocks on these food webs. It's not food webs, are they? They're supply chains. So trust me, the one on the top left is a simple fisheries one, the one on the top right is a complex fisheries one, bottom left is a simple agriculture one and a complex agriculture one, and I've got a couple of mining ones that fell off the bottom. If we randomly pretend climate is impacting those nodes and pluck them out, how much seafood gets through? And if you've got lots of alternative pathways, even as climate hits one or two of those things, the seafood can get through. And the no-brainer result is that simple food chains, supply chains, get disrupted more than complex ones. So we could adapt supply chains by adding in extra links, add in extra nodes. The problem with that is you have to diversify supply chains to build resilience, and diversification is expensive. In fact, the global economy is trying not to diversify but to streamline. So our climate adaptation solution is to keep things a bit messy and convoluted so you're resilient, but that's not the business trend. They want to be linear and highly integrated. So this uptake of this information is not yet happening. Maybe it'll take some shocks and disruption before people, seafood businesses took it seriously. And particularly, again, for this, we need data on economic values in the decision context. We can do these kind of things with product volume, but it's very hard to get the economic data to know how their performance really varies. So we've done adaptation in fish. I gave you the big tick that we can do that. Adaptation in fisheries by seasonal and decadal forecasting. Adaptation in the marketplace by the supply chains. And the last one is actually we need to adapt as scientists as well. At the moment, this bottom left is how we typically study things. As we go on with our study, we understand all of the impacts that are happening. Then we try and attribute those impacts to a particular set of drivers. And then we go on and we actually try and adapt to that. That might be in a study of a system, it might be 10 years, it might be 20 years. By the time you get to the end of that, actually the system's changed again. And what you learned about it in the impacts phase is actually over. It's time to go back to the beginning and start to understand it again. So instead, I think we need to do more of this, integration from the beginning. Start adapting as soon as we understand there's a problem, even before we know why. Just get in there and have a go with it. Learn by doing, yes. It's very difficult, though, to do that learn by doing, because we're stuck by our funding landscape. And you know the concept of peak oil production. We needed it to run our economy, but we thought supply was running out. And now we have to cope with these shortages. I think we're also entering a period of peak science. Knowledge use by society, I think, has peaked. And at the moment, there are a bunch of other things that society is using for its decision making, like social media, what my friend thinks, and so on. Friends wherever they live around the country, right? If you're an optimist, you think that situation's going to change. And there will be a change in, to speak the unspeakable, in Washington, for example, there might be a change, and optimists will go with that. The pragmatists might think, actually, things are going to go a little bit south for a while. How do we actually adapt and manage under that kind of environment? And what would fisheries decision making look like in scenario A versus B? What science do we need to do if we're really on this idea where knowledge use is going to go down? Governments are not going to support knowledge as much as they have in the past. If you're an optimist, you'll think we can keep doing the best science. We'll do great long time series, we'll do lots of process studies, big experiments, and that'll give us all the answers. If you're a pragmatist, you might start thinking, actually, we just got to work with the available science we have now and help adapt and come up with solutions. You might make more use of citizen science, industry collected science. You'll have to deal with more trade-offs. But a strength is, with more collaboration and engagement, I think that even choice B in the future becomes very doable, and we'll still be able to help things adapt, even if path B is the one that follows. So for my experience in Australia, the reasons that adaptation is working is that we have good communication. You know, that can always be improved, though, because it's time intensive. But we really think about the end user and how we can help them overcome the problems with climate change. Working relationships, again, are expensive in terms of time to maintain, but absolutely invaluable when you're trying to improve your products. Relevant timescales I bashed on already about. Build on the skills that end users already have. If they already have, for example, a business software that they use in their decision making, tune your outputs to be able to feed straight into that. There are a whole bunch of ways that as a science community we develop whiz-bang solutions, and what they just needed was a bicycle, not a Rolls Royce. Climate change in fisheries has scared a lot of people, because all that the community has emphasised is your fish are going to be gone, they'll be living somewhere else, and they'll be doing it at a different time of year. And fishers have said, well, that's going to be terrible, we've got no options. But I hope I've demonstrated that with information about the future, there actually will be opportunities. And if you're able to have a conversation about the opportunities for that business, that will open up a whole range of options. And the last one there, think about the changes in your own approaches. Be willing to try stuff and adapt even before we have information. And I hope as a science community we're gentle with each other. You know, I've got criticism before for implementing an adaptation option on the seabird when I didn't know what the cause of the problem was. But we didn't have time to discover the cause. I just wanted to try a solution. And we may try things even without knowing, the cause and effect. And that's a risky place to be. So I would say climate adaptation for fisheries is challenging. But because of the pace at which it's happening, let's not waste time. Let's get on with it and start helping these businesses adapt. Scientists who are flexible and willing to work with flexible managers will make a lot of progress. And again, I think our experience in Australia with the industry relationships has been really important, as well as the managers. And then you learn a lot by practicing. So doing seasonal forecasting gives you lots of opportunities to learn when you were wrong and what the industry did with that particular information. So try and learn stuff really quickly. That might mean doing monitoring a different way, because you will need to gather information on something else about how the system is responding, and that deserves a lot more attention. And I think I'll take a breath after that, and thank you for your attention. Thank you.
Yeah. Your projections, and then the second piece you were looking
I have more experience of that with aquaculture, but in their cases, they're planning a business cycle of about 3 to 4 years. So you plant your fish and you know you're going to harvest those in 4 years' time. And so their supply chain has a, if you like, a lead time of 4 years. And our forecasting is not able to do it that long, but we're providing information for the first 6 months that they put into their production models, and then it takes the climatology after that. So by supply chain, it will vary, but it's going to be longer than the fishery prediction timescale for sure. Yeah. The relationship is pretty good because our crunch in fisheries was about 10 years ago when we did a huge effort reduction in Australia. And then since then the relationship's been good, and it's managed through, we call them resource assessment groups that are combinations of scientists, managers and fishers that are responsible for each fishery. And so then they're individual fishery-based management groups, not regional ones. And the relationship in those, I think, is pretty strong. Yeah. The industry does get attention for its greenhouse gas emissions, and so, for example, there's moves to have more energy efficient engines in fishing boats, for example, and we think that people who get their heads around adaptation and are being active there will be more amenable to thinking about the mitigation options as well. But from I don't have any experience in that particular space. Yeah, but I would think there would be co-benefits, if that's what you're asking, in a sense that adaptation being successful should have the co-benefit of feeding over to perhaps their mitigation activities.
Yeah, I'm still thinking about that at the local level, but
yep.
Also at a global or social level. So, for instance, in the citizen science work I do, we understand that folks that are getting out with us and collecting the information as part of the process are far more likely to do things like call the governor or write the president.
Right. Yeah, right. No, I have no experience or thinking at that scale.
So what do you mean by deep science? Deep use of science? We're not going to forget what we know now.
We're going to stop using it. I think science used to be 90% of the decision-making rationale. I think that's past now. You know, economic considerations, social considerations weigh much more heavily in the decision-making context. So my peak is in the use of that knowledge in the decision to be made. Yeah, I think.
Discriminating between economic sciences not being useful,
No, I distinguish economic science from economic reasons. Same as social science is not the same as social trends. Yeah. Yeah, it's the use of it, but it will disappear because the funding won't be the same. So the community that's going to generate that knowledge, I think, is contracting as well. I think we've seen that in Canada. We've seen Australia's been through it. The US, you might be about to experience a bit of that downsizing in government funding, for example, that would mean even the generation of knowledge will go down as well as its use. We can have a pick-me-upper on that, though. I got a way it comes back. We did a period of historical hindcasting where we ran the model for the last 10 years and looked at where the catches were really taken, and were able to verify that our model accuracy was about 90 to 95% accuracy. In the first 3 years of use, Actually, we haven't looked again to see how well it's performed because we have 10 years of history of how it's performed. But I know from going tagging out there once that the only place we could find fish was the one spot that the model we were producing was saying the fish should be, and that was a really tiny area, and it was the only spot we found fish. So I've got a personal n=1 of using the forecast in another project. Yeah.
Also, the gold-colored areas were like pretty large.
They're very large.
So how do they find the fish located in that colored area?
That's right. They've got to get their tow cage to that coloured area. Once it's there are going to be fish around, and they use aeroplanes to find the fish on a daily basis. And then the cage only has to go a small distance within that good spot. But if the cage is completely in the wrong spot, even as the plane's finding fish, the cage can't get over there. And so they've got an operating range of about 20 kilometres a day once the fish are found. Yeah. It's where to tow the cage. Yeah. Yeah. And I should have said it's a quota managed fishery. So we're not helping them catch more fish, we're helping them to catch it more efficiently. So we're not helping an overexploitation problem. Yeah.
You mentioned things that the practice, for example, reducing the bycatch would be maybe one of those.
Yeah, can do that.
It's clear to me that another potential consumer of this kind of information are the governments and managers in trying to generate establish efficiently.
Yeah.
But in Australia, I'd be a tough example here, but let's say you've got two countries that are close by each other. If you're a country whose fish are heading north out of your waters, your incentive to invest in the management of water nets goes down. Versus if you're a country who's going to be receiving some fish, your incentive to try and make sure that thing doesn't come to you as a direct over fish species goes up.
Hmm.
I guess I'm just wondering, do you have a sense from your work now as a leading government as well? Is there actually a market for that? Or do you get to talk with managers and government about kind of that level of management for
Yeah.
forecasts? Or not just kind of fishing decisions, but kind of how do we think about managing these things as rates of shipping kind of move into more multinational fisheries and non-fisheries?
Yeah. As only a single country within Australian waters, our issues are when fish move across state boundaries, and someone who's been a good steward is going to lose access as they go across into the other waters. And at the moment, the solution is to negotiate access for the original fishers to keep coming with them and not empower somebody else who did nothing. That would be much harder in an international situation. And one example is in the Pacific, where long-term projections are showing that tuna are going to move from the EEZ of country A into the EEZ of country B. At the moment, those countries sell the fishing rights to China and Taiwan. If those countries know those fish are no longer going to be there in 20 years, they're going to stop buying those contracts. And so in that case, information is going to be to the disadvantage of those Pacific Island countries. So in some cases, information about the future might, make one country a winner and one a loser. And so I think you'd want to get your kind of policy sorted out ahead of time before you got a perverse effect of that. Yeah.
So you showed an example of tuna being sensitive to SST.
Yep.
Are you doing any sort of index systems for species that respond to other environmental cues? And there's, SST we get that directly from the climate models, but some of the other aspects of the ocean may be a little more problematic.
Yeah. Often when you build a historical model, you can use chlorophyll. You might have a bit of information about mixed layer depth that's pretty good. A bunch of environmentals that we can measure can go into a model, but when you want to make a forecast, your climate model doesn't produce those. And so what we tend to do is build the best one we can now, see how well it performs with the reduced data set, and then decide if we could use it in forecast mode. But there are a bunch of other variables that we'd love to have. Chlorophyll's the one that most of the biology projection community is waiting for. Other ones would be having models that are at such resolution that we can get features like eddies or fronts out of them. So you need 4 to 10 kilometre resolution ocean models to see that. Yeah. SST does, as you know, gives a lot of predictive power for biology, but you can do better with some of those other measures as well. Yeah.
Is there competition? So let's say you work really well with the fisheries and they give you all this data and you're giving them a product that they really use, and you give them a forecast, and that forecast, and they use it to some extent, and you go, how'd it work? And they think, good, great, keep doing it. And did they are they happy to share the data with you for that year and what they did and that information, or is that one of these things that you don't want to get hurt in forecasting these forecasts? And the last thing you turn stuff out to share that information.
Yeah.
They did.
Yeah.
So you end up with the same situation in fisheries where there's competition, so
No, not with regard to vessel location, because that's required to be reported and we can get access to that. But as I said, the economic value of the decisions that they made, though at the moment they're not sharing that with us. Yeah, despite what we thought was a really good trusted relationship. Yeah, yeah, yeah. One example in Australia is we export abalone into China. It's actually exported illegally and it goes through with side payments through Hong Kong. That's a pretty linear supply chain. That was disrupted by the SARS virus and also by border issues at another time. And so the supply of abalone completely stopped out of Tasmania. And so that was an example to them of how they needed to diversify, try and get into the US market, Japan. And so out of these shocks, there have been examples where they accept we'll have to take a lower price so that we're guaranteed of always selling some fish. As I said, we haven't had success with getting them to diversify it for climate change yet, and I think that's because of how many members are in a supply chain. They've got 20 odd links in them. They don't talk to each other all the time anyway. And here are us coming along with we got an answer for you about what you need to do differently. We just don't have any credibility with that diversity of stakeholders yet. Yeah. I could imagine a big government, though, saying you can only send 50% of your catch through any one airport or to any one producer, but then they're kind of business restraints, and our governments don't like putting those impositions on industries.
Based on the resistance to them sharing the economic information, speculate the motivation for doing that. Is it, would it want to share it with the government? Would it want potential investors to know? Business partners? Where do you think, where is there a lack of comfort?
I think with their competitors. In the case of the tuna fishery, we still recording? We're still recording. Yes, they're competitors. No, I'll just say they're competitors, and so they often don't like sharing that. With some of the salmon businesses that we do forecasting for, they've told us that our $50,000 project saved them $100 million in 1 year by them being able to better adjust their production schedules. It's a pretty dramatic return on investment, but if they would actually give us that formally, we'd be giving that a good hard workout, believe me. Yeah. I mean, this is big money that you can save if you understand what the environmental variability is doing. Yeah. We'll get it eventually. Yeah. Yeah. Thanks.
I have one question. CSIRO over the year, we're sitting here in Seattle over here, and there's all this pressure for the scientists, the partnership with the industry and CSIRO. That may happen in different disciplines in government agencies in the U.S. But do you feel like that's for what you do? Is that been an advantage or a disadvantage?
Yeah, it's absolutely an advantage, and we can use our government funds to actually co-invest with an industry partner. And as I understand it, NOAA has difficulty with using its APPROP money, for example, to co-invest, because then it's using public money for private benefit. We are still free of that at the moment. So, in a discovery project, we can actually offer some money to match industry's money to solve a problem. Yeah. 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 Is it? You editing that out as well? Yeah.
Okay, any other questions for Alistair? I think Alistair's here all day tomorrow, is that right?
Yeah.
And Dave has, well, he's here.
Yeah.
Thank you all for coming.
Okay, thank you.